gravitational potential energy. Next one more, elastic potential energy, electrostatic potential energy, magnetostatic potential. Again, potential energy of variety of things. We focus here on gravitational potential energy. So the symbol for this will be U. So it's given by mgh. So I'm saying the virtue of position. So what do you mean by this virtue of position? So let's take a example itself. So there's a 2 kg block I kept here. There's a 1 kg, or there's a 3 kg block, and this is say like a 4 kg block. This total height is say 10 meter, and let this be say like a 4 meter. Now how to express potential changes? So here what happened, I had to define position. Position means always we measure position from reference point. So here I define this is h equal to 0. This is the first case. Then we'll calculate the potential energy of system. So at what height the block 2 kg is there? 2 into g into 10. Let me directly write the values. Plus, what about the 3 kg block? 3 into z. What is the position of it at h equals 0? What about 4 kg block? 4 into g plus 4. So this will be 200, 0. This will be 160. So how much? 360 joules. This is the first case. Now second case, in the second case, what happens? The student, he will define, because the definition, the word says no position. So what is the meaning of that position is what I'm trying to explain here. So instead of this, the student, what happened? He will define this is h equal to 0. Okay, let's calculate the potential in this case. The same system, no, we didn't change anything. You see, they are like that only. The student who is writing potential, he will define h. He will define h equals 0 at various points. So then, what is the height at which 2 kg block will be there now? Will be 6 meter plus 6. You write it. Then what about 3 kg block? 3 into g minus 4 plus 4 into g into 0. So this is 2, 10, 120, 12 minus 3, g is how much? 10. This will be 120. We got 0. Third student, what happened? He will come and define like this. This is very simple problem, but very good concept is there. If you look at some SU or Mono, he has asked some questions where you must have a basic idea. It's not like, see, all SEO problems are not just like seeing and answering. You are supposed to assume a diagram. Third case, you will define h equal to 0, this one. The student, what happened? Third student will define this 0. So U3 is equal to 2 into 3, 0 plus 3g minus 10, 4g. So this will be minus 6. 0. This will be minus 300. 24 minus 240. Who is right? Who is correct? Question comes. The potential energy measured by 3 different students are different here. So what do you mean by the first student? Where where was the first student? The first student was here. He was on the ground. And he measures. Second student, he was here and he will measure. Third student, he was here and he will measure. Tell me like who is right among all? All 3 are correct. Sir, what is this like? Because what is the definition says? By virtue of position. There's a meaning. If you just remember that word, potential energy possessed by body by virtue of position. What you have just remembered sentence. You don't know meaning. This is what happens in physics. Most of you what happen are gathering information, not analyzing it. See, physics, for every sentence there is a diagram. If you can accept this, I think you'll change. Still, if you feel like sentence is there, okay, I'll read it, okay, I'll remember it, gone. There's the problem arises. So you're reading SU Verma. So to read one page, I feel you need 4 days. That's what the physics here. There's a way of learning physics here. But things are not happening like that, no, today. I think if I ask you to read, no, I think the 10 pages you'll read within 1 hour. I say, okay, we have read, sir. That is not called like a reading in physics. In physics, reading means what every sentence or every some 2-3 sentence, no, where the full stop will be there, where it will start, where it will full stop, no, there'll be some situation with it. So read, read in that way, analyze it. Don't bother about solving much numericals. Say again, don't spend only reading and drawing diagram, because say physics, it's all about the numericals again. So, but when you're reading the theoretical part, you should analyze with the situation, not just like a reading and remembering. There's a wrong way of learning physics. So the basic definition, what it says, potential G, energy possessed by body by virtue of position. So potential G can be negative, can be positive. Yes, potential G can be, I'll write it here now. Potential G of a system can be positive, negative, or zero. It can be anything. It all depends upon where you are taking reference point. So first case I got 360, second case I got 0, third case I got negative. What we are discussing is a gravitational potential. Sir, is it a mechanical energy? Yes. The sum of the kinetic plus potential of system is called mechanical. Means only gravitational will you bring in the mechanical? No, even the elastic potential of spring will come category of mechanical. Electrostatic potential, it will also come under category of mechanical. Magnetostatic, it will also come under category of the elastic potential energy. So, or say mechanical energy, that one. So mechanical energy means what are the examples of what is a mechanical energy? We say it's a sum of kinetic energy plus potential energy. Basically symbol what we use, E equal to U plus K. So now look at this. What about the U again? Potential are of various kinds. What are that? Gravitational, elastic, electrostatic, and magnetostatic. One more is there, even the fluid energy or pressure energy, better you call. As our chapter proceeds, we are going to add all these types of energies to this one. Mechanical energy is not only kinetic plus gravitational potential. Even all these are. As we proceed to the different chapters, no, we just add up the quantities for this one. So if you look at the advanced papers, no, you'll get do mixed problems. All different types of potential energy will come into picture. You don't have to bother. The same concept what you learned here going to apply there also. Okay, this is about the initial idea. So tomorrow it's a, I think your theory got over. To be frank, almost the work point chapter, no, the work done this week syllabus. They're the basic things. Rest all everything what we do are based on the numerical, that one. They're the basic, the idea of this chapter, the core idea. We just go for application like equilibrium, net force should be zero. We define some equilibrium. Already you know spring force. I'll bring elastic potential of spring and how it is related. The core idea is what I put it here. Okay, tomorrow we'll discuss some conceptual as well as numerical problems solved. Okay, thank you all of you.
Thank you.
Thank you, sir.